Welcome to Mr. Tompkins EdTech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers identities. I've taken related questions from my past paper walkthroughs and given them to you here back to back. These compilation videos will give you a deep dive on topics you are still finding challenging, giving you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 1. Which of these is a correct identity? Circle your answer. Okay, now you can tell these are identities, not equations, because of the triple equals sign in the middle. Okay, now what is the difference between an identity and an equation? An equation is true for 1 or 2 or 3 or 5 or some values of x, whereas an identity is true for all values of x. Okay, so if you have a look at some of the things we've got here, let's take this second one, 6x equals 18. That is true when x is equal to 3. 3 lots of 6 is equal to 18. But it's not true when x is 4 or 5 or any other value. So this is true for a particular value of x, but not all value of x, so it's not that one. You can do the same thing with 2x plus 1 is equal to 7. It's an equation in x. It's true for a particular value. I think x is equal to 3, but it isn't true for any others, so it's not that one. And same for this one at the end. Now, the first one is true for any value of x. If you make x equal to 2, then x plus 4x would be 2 plus 8, which is 10, and that is the same thing as 5 lots of 2. And that works if you subbed in any value of x. It's always going to be true. So that is the identity. It's always true for all values of x. Question 3. Circle the identity. Well, identities have 3 lines like that, so that one is the identity. The others are an expression, an equation, and an inequality. Question 4. Circle the correct statement. Okay, now each one of these statements has got a 3-lined equal sign in it. That means it's an identity, and that means it must be true for all values of x. Okay. Now, equations are just generally true for one value of x. So for instance, that second one, 3x is equal to 2, that's true when x is 2/3, but it's not true for any other value. So it's not true for all values of x, it's just true for one. Similarly, 3x plus x equals 2 minus x, that resolves to 4x equals 2. And again, that would be true for x equals to half, but it isn't true for anything else. The next one, again, resolves to the same thing. So that's only equal to x equals to a half. But this one here, look, 3x is identical to x plus 2x, or x plus 2x is 3x. 3x is equal to 3x, isn't it? Because whatever value the x is, that is always going to be true. So that is the one that's always true. The other ones are only true for particular values of x. So they're not identities, they're just equations. Now, question 7. Work out the values of a and b in the identity. And I've got 5 lots of 7x plus 8 plus 3 lots of 2x plus 4 is identical to ax plus 13. Okay, so I've got quite a complex expression on the left-hand side of my identity symbol and a fairly simplistic one on the right. Now, when you've got identities, these are not like equations that you have to solve. We're not trying to move things over the equal sign and simplify it down. What we need to do is make one side look more like the other so we can more directly compare them. Okay, so what I'm going to do is I'm going to start off with one side, and it's usually best to start with the most complex of the two sides and make it try to make it look more like the other side so we can more directly compare. So let's start with the left-hand side, because that is the most complex. So I'm going to write down LHS for left-hand side, and that is 5 lots of 7x plus 8 plus 3 lots of 2x plus b. Okay, So we're just going to work on one side. We're not going to move things over. You'll get confused if you do it that way. So first off, let's simplify it by multiplying out the brackets. So outside the bracket, number outside the bracket gets multiplied by everything inside. So 5 times 7x is 35x, and 5 times 8 is 40. And the second bracket, 3 lots of 2x is 6x, and 3 lots of b is 3b. Okay? So I've got some like terms here. I've got two terms in x, 35x and 6x. So let's bring that together and make 41x. And I've got 3b plus 40. Now that's all part of my constant, isn't it? So I've got 41x's plus my 3b plus 40. Okay? Now we know that that is equal to ax plus 13. And now we're in a position I can more directly compare them. Let's have a look at this coefficient of x here. The coefficient of x on the left hand side is 41, and on the right hand side it's a. So if we're saying that these two things are identical, then 41 must be equal to a. Similarly, if I know that these two things are identical, then the number part must be equal as well. So my 3b plus 40 must be equal to 13. So if 3b plus 40 is equal to 13, then rearranging that, subtract 40 from both sides, and we're going to get 3b is 13, subtract 40, which is what, minus 27, and then divide both sides by 3. B is going to be minus 9, then, isn't it? Okay, so A is 41, B is minus 9. Question 9. Work out the values of A and B in the following identity. Okay, so we've got a complicated left-hand side and a little bit more of a straightforward right-hand side, and we need to work out the values of A and B. So basically we're going to be comparing coefficients here, but before we do, let's see if we can simplify the left-hand side a little bit so it's a bit easier to compare. So the left-hand side is 3ax plus 6 minus 4 lots of x plus b. Now removing the brackets, I'm going to get minus 4x minus 4b. I want to collect the like terms together. So I'm going to get 3ax minus 4x plus 6 minus 4b. And then factorising out the x, I'm going to get 3a minus 4 lots of x plus 6 minus 4b. Okay, now that is identical to 11x plus 14. So what I can do now is I can say, well, this coefficient of x here, if it's identical to the other expression, must be 11. And this constant I've got on the end must be the same thing as that constant over there. So I can form two equations now. I can say that 3a minus 4 is equal to 11. And I can say that 6 minus 4b is equal to 14. So I can, well, they're each linear equation, so I can solve both and find an a and then b then, can't I? So 3a is equal to 15, making a equal to 5, or 6 minus 14 equals 4b. So minus 8 equals 4b, making b equal minus 2. So b is minus 2 and a is 5. Question 13 has an identity and it's asking how many values of x is x multiplied by x plus 4 equal to x squared plus 4x. Well, the very fact that this is an identity, it's got 3 lines there, not 2, which makes it an identity. That means it's true for all values of x. That's what an identity means. So that's done. Question 14, we've got x plus 2 times 3x plus a times bx plus 3, and that's equal to 6x cubed plus 11x squared minus 17x minus 30, and we need to find the values of a and the values of b. Okay, now I think what we're going to do here, we've got triple brackets, which I'm going to try and multiply out as best I can and then compare them with the other side to see if I can work out what the values of a and b are, using a technique called comparing coefficients. So I'm just going to start with one side. So I'm going to start with the left-hand side of this. I don't want to deal with everything all at once. So I'm just going to start with the left-hand side. So I've got x plus 2 times 3 times 3x plus a times bx plus 3. So I'm just going to ignore the last bracket and just kind of do FOIL on the first two brackets. So just multiplying that with that, that with that, that with that. So what I get is x times 3x, which is 3x squared, and then x times a, which is ax, and then 2 times 3x, which is 6x, and then 2 times a, which is 2a. Okay, so that's what I get when I multiply out those two terms. Okay, and then I need to carry on multiplying it out. Now I need to multiply everything in the first bracket with everything in the second bracket. Okay, so I'm going to start off by multiplying everything through by bx and writing it down first. So 3x squared times bx, that is 3bx cubed. And then I've got ax times bx, which is abx squared. And then I've got 6x times bx, that's going to be 6bx. And then I've got 2a times bx, which is 2abx. Okay, so I've multiplied everything in the first bracket by bx, and now I'm going to multiply everything in the first bracket by 3. Rather than writing a big long line, I'm just going to drop down the line, and I'm going to start doing it from here. So I kind of, you'll see why I'm doing it that in a sec. So 3 times 3x squared, that is 9x squared. And then I've got 3 times ax, that is 3ax, and I've got 3 times 6x, which is 18x, and I've got 3 times 2a, which is 6a. Okay, right, so now we need to kind of combine all those together. So you can see I've got terms in x, I've got terms in x squared, I've got terms in x, which is here, 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 and here, and then I've got a term in, well, a number on the end, which is our constant on the end. Now what I want to do is I want to compare that to this thing up here that we wrote and that we had up here. So that is all equal to 6x cubed plus 11x squared plus, right, all four of these are going to be, oh sorry, minus. It's going to come to minus 17x, and then I've got minus 30 on the end. Okay, so if you think about it, that's that it's 3bx cubed matches up with this 6x cubed. So comparing coefficients, we call it. Compare coefficients of, first off, x cubed. What's that going to give us? So the x cubed coefficients, I've got 3b on one and I've got 6 on the other. So if these two expressions are equal, then they've got to be equal as well, haven't they? So 3b has got to be equal to 6, which tells me that b is equal to 2. Okay. Now I could look at the second one, but that hasn't got any a's in it, so that's no good. So I'm just going to have a look at this one on the end. So I've got 6a, and that matches up with 30 down here, or minus 30 actually. So comparing the constants, we've got 6a is equal to minus 30. Okay, right, so that gives me A is equal to negative 5. So A was negative 5 and B was 2. Okay, now a lot of this work here was superfluous. In fact, all of this bit in the middle, look, all this bit in here I didn't actually use or need. Okay, so actually you could have just shortcut this by just thinking about what term delivers you the x cubed term, and just kind of thought, well, that times that is going to give me my x cubed term, and that's going to be equal to 6. And what term delivers me the constant at the end? Well, it's that term times that term times that term. So you could have done it that way and saved yourself a bit of work. I've kind of done it long. It's only worth 2 marks, but hopefully you can see why it is what it is, and decide whether or not you want to kind of do a full method or just kind of focus in on the x cubed term or the constant term, and kind of do it a bit faster. Question 15. I've got x plus a times x plus 3a, and then that is equal to, with a triple equal sign, x squared plus bx plus 75. Work out 2 possible values of b. Okay, now first notice this weird symbol in the middle. That's not an equal sign, is it? It's actually an identity, and it means that the expression on the left is identical to the expression on the right. So it's not just the same thing as equals, which would imply that's equal to for some value of x. This it's like a super equals, and it means it's valued it's equal for all values of x. Okay, so I think what we're going to do is we're just going to simplify this bit on the left by multiplying out the brackets, so we can compare what we've got a little bit more easily. Okay, so let's just work on the left hand side to start with. So using FOIL, which is first, outside, inside, last, or 2 eyebrows and a nose and a mouth, I'm going to multiply those various things together. So x times x is x squared. X times 3a is 3ax. A times x is ax, and a times 3a is 3a squared. Okay, now that is all equal to what's on the right hand side. Right, I've not quite finished simplifying the left hand side yet though. Now I've got a term in x squared here which kind of matches that one. Let me just write that down again here. Now next I've got 3ax and ax. If I add them together, 3a plus a, well that's 4a, isn't it? So that comes to plus 4ax. Okay, and then finally I've got 3a squared on the end. Now that is identical to x squared plus bx plus 75. Okay, now if these two expressions are identical, then every part of it must be identical. So that x squared must be the same as the x squared. It is. But more than that, this 4a in front of the x must match up with that b there. Okay, now we call this comparing coefficients. So comparing coefficients of x, that gives us 4a is equal to b. Okay, and now we can also do that with the constants at the end. This 3a squared, if these two things are identical, these two constants must be the same as well. So that 3a squared must be equal to 75. So we're going to call that comparing constants. That's going to give us 3a squared is equal to 75. Okay, so you can see we've got a pair of simultaneous equations. The first one's actually linear and we can solve it for a. Once we know that, we can sub it into the other one and we can solve it for b. Okay, so we're going to take equation 2 and use that one first, aren't we? So let's take equation 2 and simplify. Let's just divide both sides by 3 to start with. So that's going to cancel with that. And that's going to leave me with a squared is equal to 25. And then to simplify that, we're just going to root both sides, aren't we? Okay, the root of a squared is a, and the root of 25 is 5. So that's going to give me a is equal to 5. But steady on, when we square root something, there is actually 2 possible solutions, aren't there? So to get our 2 solutions, this is where we're going to say, well, it could be positive 5 or it could be negative 5. Okay? So there are actually 2 possible values of a, plus 5 or minus 5. And they're going to give me 2 different values of b. Okay? So if a is equal to 5, what is the value of b then? So then 4a is going to be 4 lots of 5, and that is equal to b. So that means that b is equal to 20. And if a is minus 5, then that means 4 lots of negative 5 is equal to b, and that means that b is negative 20. Okay? So we got 2 solutions. We've got a is 5, b is 20, or we've got a is minus 5, b is negative 20. Okay? They're my 2 solutions. In question 17, we have an identity. We've got 2 expressions and we're told they're identical to each other. And we need to work out the values of a and b. Okay, just take care with these sorts of questions. This is an identity, so it's true for all values of x. We're not trying to solve for x here or anything. So we're not going to be bringing things, crossing things over the equal signs and trying to drill them down onto the answer. Instead, what I've got is, I've got 2 different expressions involving x and some other things, and I'm told they're identical, so they're equal to each other for all values of x. So what I'm going to do instead is I'm going to take one side of the expression, and it's usually a good idea to start with the more complex looking one, and make it look more like the other side. So I'm going to start with the left hand side of my expression. And I'm going to try and simplify it out by multiplying out all the brackets and collecting all the like terms together, and then try and make it more look like the other side so I can compare coefficients. Okay, so first up, removing the brackets using whichever method you like best. I'm going to go for 2 eyebrows, a nose and a mouth. So 3x times x is 3x squared. 3x times minus 2 is minus 6x. 1 times x is x, and 1 times minus 2 is minus 2. Don't forget my other 2 terms, ax and b on the end. Okay, now I can start collecting like terms together. I just have the one term in x squared, so I'm going to just leave that at the front. But for my terms in x, I've actually got 3 different terms. I've got a minus 6x here, a 1x here, and an ax here. So I can say that what I've got is an a plus 1 minus 6, which is minus 5. I've got a minus 5 lots of x. And then finally, my constants on the end, I've got a minus 2 and I've got a b. So plus b minus 2. Okay, so you can see now I've multiplied out all the brackets and I've collected all the like terms together. So now I can start comparing it with my right hand side above. So my coefficient of x squared matches with that coefficient up there. So we're saying that this is equal to 3x squared plus 8x minus 5. So that bit and that bit are identical. And then, so my a minus 5 lots of x has got to be equivalent to that 8 there. And finally, I've got a b minus 2 on the end, and that's got to be equivalent to this minus 5 here. So now I can equate coefficients. I can say my 3's are equal to my 3. So coefficients. I know that a minus 5, my coefficient of x, must be equal to my coefficient of x, must be equal to 8, which means that a must be equal to 13. And my blue ones, my b minus 2 must be equal to minus 5. So b must be equal to minus 3. So just need to write that in the box below, 13 and minus 3. Question 18. Here is an identity. X squared minus y squared is identical to x plus y, x minus y. Now you should be very familiar with this identity. It's what we call the difference of two squares. I've got two squares that I'm subtracting or finding the difference of, and we're told that that's x plus y, x minus y. Okay, so use the identity to work out the value of 193 squared minus 7 squared. You must show your working. Okay, so what we're going to do is we're going to take 193 squared minus 7 squared. And rather than working out 193 squared, this is a non-calculator paper, isn't it? It's going to be tough. I'm going to use my identity instead. So if I've got two things, one thing squared minus the other thing squared, that's the same as the thing plus the thing, other thing multiplied the thing minus the other thing. In other words, 193 plus 7 times by 193 subtract 7. Okay, so 193 plus 7 is 200, and 193 subtract 7 is 186. Okay, so then we need to multiply these two things together. So multiplying 186 by 2 and adding 2 zeros on the end should do the job, shouldn't it? So what's double 186? Double 18 is 36. That'll be 360 plus 2 sixes, 372. So 372 plus my 2 extra zeros. So 37,200. Right, in question 18, we've been given an identity that 12x cubed plus 7x squared plus 3x minus 10 is identical to 2 lots of ax cubed plus x squared plus 2x minus 5 plus x lots of bx plus c. And we need to work out the values of a, b, and c. Now take note here, this is an identity. This is not an equation that we're trying to solve, so we don't want to be moving things over the equal sign, well, the super equal sign here, the identity symbol. We want to make the two sides look more like each other so we can directly compare them. Okay, so I'm going to just work on one side of this, not both, and I'm going to start off with the right hand side. Okay, so you can just use the abbreviation RHS, right hand side, and I'm just going to multiply out this bracket here, multiplying everything in the bracket by 2. That's going to give me 2ax cubed plus 2x squared plus 4x minus 10. Okay, and then I'm going to multiply everything out in the second bracket, so everything times by that. So x times bx is bx squared. When I do this and I've got a long expression like this, I tend to stack similar terms on top of each other. So x times bx is bx squared. So rather than writing on the end here, I kind of like to write it underneath the other x squares. It just makes adding them up later easier. And then I've got x times c, that is cx. Okay, so if I do it like that, then it just makes it easier to collect those together. Okay, so that gives me 2ax cubed plus 2 plus b, collecting those together, lots of x squared, plus 4 plus c, lots of x, minus 10. Okay, now once I've got it like that, you can see now I've got it in a similar form as the other side, where I've got let's just get rid of that color. So that 12 there, the coefficient of x cubed here, has got to be the same as this one. Okay, the 7 here has to be the same as this. The 3 here needs to be the same as this, And look, I've got a minus 10 on the end on both. Minus 10, minus 10. So what we're going to be doing, this is a process called comparing coefficients. So we're going to compare in coefficients here. Okay. Now starting off with the x cubed coefficients. So on the left hand side I've got 12, and on the right hand side I've got 2a. So if 12 is equal to 2a, that tells me that a is equal to 6. Okay. Now comparing the next coefficient, x squared, what have I got there? So for x squared I've got 7 on the left hand side, and I've got 2 plus b on the right hand side. So that tells me then that b must be equal to 5. Okay, and then comparing the x term, I've got 3 on the left, and I've got 4 plus c on the right. So that tells me then, well, if 3 is equal to 4 plus c, then c is going to have to be equal to minus 1 then, isn't it? And there are my three values then. A is 6, b is 5, and c is minus 1. In question 23, we are given an identity. 2x squared minus 20x plus c is identical to a, open brackets, a minus b all squared plus 3b. Now take care here, this is not an equation that you want to solve. You're not wanting to be moving things over that identity from one side to the other. What you want to do is you want to take one side and make it look more like the other, so we can compare all the coefficients and read out the values of a, b and c. So I'm going to take the right hand side of this identity and I'm going to make it look more like the left hand side, and then so we can read off the values. Okay, so I'm going to start off with the right hand side, and that is equal to a lots of x minus b all squared plus 3b. Now multiplying out the brackets, if you're not very good at brackets you might want to write those two brackets out, x minus b, if that makes it easier for you. And then so that's a lots of x squared minus bx plus b squared plus 3b, which is a lots of x squared minus 2bx plus b squared plus 3b. Okay, removing the brackets, multiplying everything inside the bracket by a, I'm going to get ax squared minus 2abx plus ab squared plus 3b. Now I finish multiplying them out, you'll see that I've got something to do with x squared here, ax squared, and that's got to be equivalent to my 2x squared in my original identity. I've also got something to do with x. I've got minus 2abx, and that's got to be equivalent to that minus 20x there. And I've got some numbers on the end, some constants on the end, which must match up with my constant on the end of that. So I can pair them up. I can say, well, if ax squared is equal to 2x squared, then a is equal to 2. I can say that the 2ab must be 20, and I know that a is 2, so that means 2b must be 10, so b is equal to 5. And I know finally that ab squared plus 3b must be the same thing as c. So c equals ab squared plus 3b, which is 2 lots of 5 squared plus 3 lots of 5, meaning that c is equal to 2550 plus 1565. So C is equal to 65. Question 26. We've been given kind of a complex identity here. It's a cubic, isn't it? It's got 3 brackets multiplied together, and that's equal to x cubed plus bx squared plus cx minus 30. And we're asked to work out the values of integers a, b, and c. Now, when you've got an identity like this, you can tell it's an identity because it's got 3 lines there in the equal sign. This is not an equation that you need to solve. You don't want to be moving things over from one side of the equation to the other to solve it, or dividing both sides by things. What you're going to be doing is you're going to be comparing. You're going to be comparing this part with this part. And then, so I'm going to just try and make one side look more like the other so they're more directly comparable. And I think the easiest way to do that is to multiply out all the brackets on the left hand side. So we're going to start with the left hand side. We're going to make it look more like the right hand side so we can compare it a bit easier. So let's take the left hand side, LHS, it's a little handy abbreviation. So the left hand side is x plus 5, x plus 2, x plus a. Okay, now we're going to take 2 of these brackets and we're going to multiply them out using FOIL. It doesn't really matter which way around you're going to do it. I'm just going to start with the first 2 first. So that times that, that times that, that times that, that times that. And then we're going to leave the second bracket alone for now, so that just stays as it is. And then we're going to work out what this bit is when I multiply out the brackets. So I'm going to get x squared, x times x. I'm going to get 5x and 2x, which is 7x. And I'm going to get 5 times 2, which is 10. Okay, so I'm going to get x squared plus 7x plus 10. So I've multiplied out those first 2 brackets. Now I need to multiply out these 2 brackets. So it's a little bit more complicated because I've got a quadratic equation, quadratic expression times a linear expression. And we're going to do something similar to FOIL, but not exactly the same because I've got more parts. Basically, I have to take everything in the first bracket and multiply it by x, and then take everything in the first bracket and multiply it by a. Okay, so multiplying the first bracket by x first off, I'm just going to write that down as x cubed plus 7x squared plus 10x. So that was taking everything in here and multiplying it with x. Now I'm going to do the same thing. I'm going to take everything in there and multiply by a. So then I'm going to get ax squared. Just going to write it underneath and offset slightly. Ax squared. Can you tell why? And then I'm going to do 7x times a, which is 7ax. And then I'm doing 10 times a, which is 10a. Now the reason I kind of offset it like that, I don't know if you see, and I've lined them up. So I've got all the x cubes above each other, all the x squared terms above each other, all the x terms above each other, and the constants on the end above each other. So adding those up, I've got an x cubed term. I've got 7x squared plus ax squared, which is 7 plus ax squared. I've got a 10x and a 7ax, which is 10 plus 7ax, and I've got a 10a on the end. Okay, right, so that's as far as I'm going to get with this, I think. So I've multiplied out all those brackets, but you can see now I've got like a sum of terms here now, which is a bit more like the blue part of the right hand side. Okay, so let's compare it now with the right hand side. We know from before that I'm copying the bit down in the blue part now, that x cubed plus bx squared plus cx minus 30 is what I had in the blue part there. So now I can do something called comparing coefficients. If these two things are identical, then the coefficient of x squared from the left hand side must be the same thing as the coefficient of x from the right hand side. In other words, 7 plus a must be equal to b. Okay, so I'm forming an equation from comparing the coefficient of x squared in the two forms of my identity. I could do the same thing with the x terms. I've got 10 plus 7a there, and I know that's the same thing as c, because that's the coefficient of my two x terms from the two expressions. So 10 plus 7a is equal to c. So I've got that from the green bits. And then finally, my constants on the end, my 10a and my minus 30, they must be equal to each other as well. So 10a equals minus 30. Okay? And I got that from there. So I've got three equations, three unknowns, a, b, and c. Okay? Well, a is pretty easy to find because 10a is minus 30, so that makes a equal to, divide both sides by 10, it's going to be minus 3. So I know that one already, it's minus 3. Once I know that a is minus 3, it's pretty easy to work out b from the yellow equation. 7 plus negative 3 is equal to b, so that makes b equal to 4. Okay, and once I know b is 4 and a is minus 3, I can then work out what c is as well. So 10 plus 7 lots of minus 3 is equal to c. So it's 10 plus 7 times 3 is 21, so 10 take away 21 is negative 11. So c is negative 11. Okay, that's it, done. So just going back up to the top, don't be tempted to move things around from one side to the other. It's not going to work in an identity type question. You need to get one side looking like the other and then directly compare all the different bits of it. Okay? 3 marks. That's very stingy. Just thinking if I've done it the long way. I suppose you could do it a little bit more ad hoc. You could have just kind of thought that you know, that times that times that has got to give you the minus 30, and kind of done it piecemeal like that, finding a very quickly. I suppose that's a possibility. But anyway, 3 marks doesn't seem a lot for this question. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.